In this video, we're going to take a look at a bandwagon application using ePOP concept. Application has a forward and reverse cab with tracks. I used some publicly available data to create a drive. It's a hydraulic steering between the cabs, is a hydraulic load, and then a small electrical load. To reverse engineer both the cycle and the powertrain. If I look at the engine, was basically a 100 kilowatt engine, consumes 160 liters. That matched up with my target pretty well. So I'm happy with the reverse engineering the legacy ICE powertrain. So once we have that configuration, this is what I believe the legacy is. Now it's time to explore options, maybe electrified. So I created an electrified option. Now, instead of ICE, let's make it, there's different options to do, but we're going to explore a series plug-in version, which you can see how it updates. There's a charger with a charge time, a battery appears, genset, and then the motor. I want it to, there's different ways to deliver the power, but I think this makes sense. Basically keep the steering hydraulic, but then use a electric motor for the drive. So we now have an electrified powertrain version versus the more legacy. So once we have the electrified architecture and configuration, we can start to explore what a battery version would look like. So here we have the KPI mass. Here's the legacy ICE, no batteries, just over 500 kilograms. But if you went to battery only, which is all the way to 100% battery to complete the same cycle, same standards, you can see mass of the powertrain goes from 500 to over 3,000 kilogram. Now this is only a 6,000 kilogram vehicle, so increasing the mass by 50% is probably unacceptable. And you can see it's battery that increases it. But as you increase the battery, it actually gets worse than that, because as you increase the mass of the vehicle with battery, the powertrain actually has to grow. So there's a mass compensation that needs to be done for the increased size of battery. So if we apply that mass compensation, now if we return to the mass results, you can actually see the more batteries you put on, the more batteries you need to put on to compensate for the increased mass. So now it's over 5,000 kilograms. So unless you change the range requirements, I don't see a BEV version of the powertrain as viable. These vehicles are known for their light impact through the treads. So almost doubling the mass of the vehicle is probably unacceptable. But if you move down from a battery only, these are different degrees of electrification. So this is a hybrid. To the hybrid versions, you can actually get to parity with the legacy powertrain, or even reduce. There's a 20% reduction in the mass of the powertrain by actually going to a hybrid. Where does that come from? Yes, there's an increase in batteries increase in motors and inverters and power electronics, but there's a offsetting decrease in the ICE. You can downsize the ICE, and you're able to downsize the transmission. And then because you're running a hybridization, running more efficiently, you're able to downsize the fuel tank itself too. So this seems to be like a more viable powertrain. Now another point, another KPI is these vehicles operate in very cold climates. And if you look at I'm going to look at energy loss. As you downsize the engine to the point of, nearly battery electric, the amount of energy loss, which is waste heat, mainly comes from the ICE. You're looking at a huge drop-off in waste heat, and if you went to battery only, it would go away. Well, that waste heat isn't waste when it provides cabin heat. So if you do lose that source of waste heat, then you actually have to add back on the application. Maybe it's electric heat. You have to increase the electric heat, which is going to further reduce your range. It's basically you're adding power that's not going to the wheels. A hybrid version, even though it's less losses than an ICE only, which is good, it increases the efficiency, there still is some waste heat from the engine to provide cabin heating. So that's just one close look at the different KPIs. Volume, similar story to mass. Cost, using the cost numbers that I put in. Actually, this hybrid is the lower overall operating cost given these TCO values, 5 times a week for 10 years. If you increase the battery size, you're actually increasing the cost. Probably has to do with the mass compensation. Initial cost, operating costs. So you can start to see these trade-offs. Take a much better powertrain decision.